To manage the cargo vapor, especially in terms of ensuring a desired flow rate from the cargo tanks back to cargo tanks ashore or to the engine room for gas burning, the ship is provided with gas compressors. Normally, 2 high-duty and 2 low-duty single-stage centrifugal compressors driven by electric motors via a speed-increasing gearbox are installed in the cargo compressor room. The compressors are coupled to electric motors and mounted on a common rigid base frame together with seal gas, bearing lubricating and instrumentation control subsystems. The electric motors are located in the electric motors room, which is separated from the cargo compressor room by a gas-tight bulkhead and bulkhead shaft seals. There are 2 high-duty compressors. They are single-stage centrifugal compressors driven by electric motors via a speed-increasing gearbox. The desired flow control is achieved by controlling the inlet guide vanes. They handle gaseous fluids, LNG vapor, and various mixtures of LNG vapor, inert gas, or dry air during the cooling down, cargo operation and tank treatments. Single-stage centrifugal type. Capacity 20,000 cubic meter per hour at inlet temperature of minus 140 degrees centigrade and inlet pressure of 1.05 bar absolute. Maximum outlet pressure 1.96 bar absolute. Electric motor 650 kilowatt of EXCD type equipped with soft starting facilities. There are 2 low-duty compressors. They are single-stage centrifugal compressors driven by electric motors via a speed-increasing gearbox. The desired flow control is achieved by a combination of speed control and the adjustable inlet guide vanes. They take suction from the forced vaporizer or natural boil-off and discharge to the fuel gas heater to supply the boilers. Single-stage centrifugal type. Capacity 6,000 cubic meter per hour at inlet temperature of minus 140 degrees centigrade and inlet pressure of 1 bar absolute. Maximum outlet pressure 1.96 bar absolute. Electric motor 230 kilowatt of EXCD type equipped with variable speed control from 50 to 100%. The seal gas system prevents the lube oil mist from entering the compressed LNG vapor and also to avoid cold gas flow into the gearbox and the lube oil system. Nitrogen used as the seal gas is injected into the labyrinth-type seals between the gearbox shaft bearing and the compressor wheel. The seal gas system features a pressure control that is a function of the compressor outlet pressure. Seal gas entering the gearbox from the shaft seals is returned to the lube oil sump, separated from the oil and vented to atmosphere. The lube oil system feeds the following: journal bearing on both sides of the high-speed shaft, journal bearing on the driven end of the low-speed shaft, integral thrust and journal bearing on the non-driven end of low-speed shaft, sprayers for the gear wheels, gas compressors bulkhead seals. Lube oil in the system is stored in a vented lube oil sump. An integrated electrical immersion heater with thermostatic switch is fitted in the sump to maintain a constant positive temperature and avoid condensation when the compressors are stopped. Lube oil is supplied from the sump through separate suction strainer screens and one of the 2 lube oil pumps. The main pump is driven by the high-speed shaft gear. If it fails, the auxiliary or standby pump will start immediately. The auxiliary pump is also used to start the compressors. The pumps discharge into a common lube oil supply line feeding the gearbox, bearings and bulkhead seal. Pump relief valves are set at 7 bar. The lube oil passes through freshwater-cooled oil cooler. A temperature control valve maintains the outlet temperature at 35 degrees centigrade. The oil supply to the bearings is fed via a 25-micron automatically controlled duplex filter. A pressure control valve at the outlet regulates the oil flow to the bearings. Excess oil is bypassed and discharged to the sump. All the gas compressors are equipped with an automatic surge control system. It ensures that the compressor flow rate does not fall below the designed minimum. Below this rate, the gas flow will not be stable, and the compressor will be liable to surge, causing shaft vibration, which may result in damage to the compressor. To achieve the required gas flow, The compressors have inlet guide vanes fitted at the suction end. The vanes are operated by pneumatic actuators which receive control signals from the flow controller. Rotation of the vanes is possible through an angle of 100 degrees centigrade. The position is indicated both locally and on the Distributed Control System DCS. Each compressor shaft is equipped with a force-lubricated bulkhead shaft seal, preventing any combustible gas from entering the electric motor's room. The seals are fixed on the bulkhead and float on the shafts, supported by two ball bearings. The lube oil seal ensures tightness between the two bearings. The lubrication comes from the main lube oil circuit. Check the oil level in the lube oil sump and warm it up prior to expected compressor startup. Open compressor suction and discharge valve and the seal gas supply manual valve. Run auxiliary lube oil pump to warm up gearbox and bearings. Line up the cooler and the instrument air. Select the starting mode required on the cargo switchboard, either direct online or soft starting. Normally each high-duty compressor is supplied from a separate cargo switchboard, that is, port and starboard. Set up the cargo piping system for the operation to be carried out. In the centralized control room, select the appropriate mimic in the DCS. The inlet guide vanes must be shut and the surge valve open before starting. Check all safeties are clear and start the compressor motor. As there is no automatic control for the HD compressors, the discharge rate of LNG vapor return to shore will be controlled manually by adjusting the inlet guide vanes opening. For the low-duty compressors, the procedure is similar. Here, the inlet guide vanes must be shut and motor speed adjusted to 50% before compressors can start. Once started, the compressor control is set on automatic mode.